Imagine for a second that you have a to-do list. We all have one.
Oh, yeah. Mine's a mile long.
It's got the usual stuff on there. Buy groceries, answer emails, maybe finally use that gym membership.
Definitely that one.
Right. It's the stuff that just eats up your day. Now, imagine there is a single task you could write at the very top of that list. Just one. And if you check that one box, it would automatically complete every single other task below it.
Okay. That sounds like a dream.
Not just for today, but like forever.
I think everyone listening would pay good money for that.
Exactly. Now let's scale that up. Take that concept and apply it to the entire human race. We're not talking about groceries anymore. We're talking about the big, scary stuff. Curing cancer.
Solving the clean energy crisis.
Mapping the entire universe. What if there was one single invention, just one, that could unlock the solution to all of those problems at once?
Well, it sounds like a massive ambition. Or, maybe the plot of a science fiction novel.
It does.
But what we're looking at today isn't fiction at all. It is the actual corporate roadmap of one of the most powerful AI companies on the planet.
That's it. Today, we are doing a deep dive into the mind of Demis Hassabis and his grand plan for Google DeepMind.
It really is a grand plan.
We've pulled together a stack of analysis from his recent appearances at Davos 2026, his interviews with CNBC, and DeepMind's own, academic publications.
And the mission statement behind it all is, frankly, staggering.
It's literally solve intelligence to solve everything else.
It's such a powerful phrase. And the person behind it, Demis Hassabis, he's arguably one of the most important figures in technology today.
The source material draws this really interesting comparison right off the bat.
The Tony Stark of AI.
I love that. Who doesn't want to be Tony Stark? But is that just media hype, or does it actually, fit?
Well, the comparison is pretty specific. It's about building a digital Iron Man. But instead of a suit that flies around and shoots lasers.
Right, no alien.
He's building a digital entity, an artificial general intelligence, or AGI, that acts as the ultimate scientist. It doesn't just chat with you. It cures diseases. It predicts climate patterns.
It breaks through the bottlenecks that humans have been stuck on for decades.
Exactly.
And that's really what we need to unpack today, because I think a lot of people hear AI and they still think, oh, cool, a better chatbot.
Or something that writes my emails for me.
Which is useful. But Hassabis is playing a completely different game. We're talking about a transition from, say, digital assistants to scientific problem solvers.
And what's really striking in the research is the timeline.
The timeline, yeah. This isn't 50 years away. The roadmap he has laid out is specifically for 2026 and the years immediately after.
It is happening right now. And to really get where this is going, you have to understand who Hassabis is.
Because his background is not what you'd expect for a CEO of a major Google division. It explains the whole philosophy.
It really does.
This is one of my favorite parts of the research. His origin story is just wild. He was a chess prodigy, of course.
Right.
But then, at age 17, he was a video game programmer. He created the hit game Theme Park.
A classic. I remember that game so vividly.
I played that for hours. You build roller coasters, you set ticket prices, you try to sell burgers to these little virtual people.
It's hilarious to think about, isn't it?
That the guy who made a game where I could ramp up the salt on the fries to make people buy more soda is now trying to build a digital brain.
It is funny, but if you look closer, the trajectory makes perfect sense. In Theme Park, he wasn't just making a game, he was simulating an entire system.
A small, closed economy.
Yeah, with little autonomous agents, the visitors, who had their own behaviors. He was simulating a world.
So he went from simulating roller coasters to simulating the human mind.
That's the leap. He realized that to build a truly smart simulation, he needed to understand the ultimate system, the human brain.
So he left the games industry.
Went and got a PhD in neuroscience to study memory and imagination, and then founded DeepMind in 2010 with that specific goal, replicating biology in code.
And then Google bought them in 2014 for about $500 million.
Which, looking back now...
sounds like an absolute bargain, honestly.
A massive bargain.
Yeah.
Because look what they've done. They started with games, sure. Everyone remembers AlphaGo beating the world champion at Go in 2016.
That was the big Sputnik moment for AI.
It was. But the shift Hassabis has made recently is the crucial part. He's moved from winning board games to winning Nobel Prizes.
Literally. We have to mention this because it just gives him the ultimate credibility.
This isn't just hype.
Right. This isn't just a guy with a PowerPoint. He and his team won the Nobel Prize in Chemistry in 2024.
Correct. For AlphaFold, and this connects right back to that core mantra we talked about.
Solve intelligence to solve everything else.
AlphaFold is the perfect example of that philosophy in action.
Okay, let's break that down for a second because AlphaFold pops up everywhere in the sources. What exactly did it solve?
So think about proteins. They're the little microscopic machines that do everything in your body.
Digestion, muscle movement.
Fighting viruses, everything. But a protein is just a long string of amino acids. To work, it has to fold up into a very specific, very complex 3D shape.
Like really, really complex origami.
That's a great way to put it. And if you don't know the shape, you don't know what the protein does.
And for 50 years, figuring out that shape was one of the hardest problems in biology.
It could take a PhD student their entire career to figure out the shape of just one protein.
And Hassabis's AI just, what, did it overnight?
AlphaFold predicted the structure of over 200 million proteins.
Wait, 200 million?
Basically every single protein known to science. It did in months what would have taken humanity centuries.
So that's the meta-tool concept. You don't build a single drug for cancer. You build an AI that understands the biology, and it helps you build the drug.
Precisely. And the roadmap we're looking at today, the one for 2026 onwards, is built on 4 pillars.
This is the how.
This is the how. The source material breaks them down really well, and they basically explain how they plan to take that AlphaFold success and just apply it to everything else.
Okay, let's get into those pillars. What's pillar number 1?
Pillar 1 is exactly what we just touched on, advancing scientific understanding. This is the big differentiator for DeepMind.
Hassabis isn't focused on making an AI that can write a funny poem.
Or generate a picture of a cat in space. Right. He wants AI that accelerates hard science.
The source mentioned that they're looking at physics and chemistry next. There's a great phrase in there, using AI to wrangle the molecular universe.
I love that image, wrangling the molecular universe. It's all about material science. Think about batteries.
We need better batteries for electric cars. Lighter, more charge, not using rare earth metals.
And discovering a new material for that is usually just trial and error. It takes years.
Like Edison trying 1,000 different filaments for the light bulb.
Exactly. Hassabis wants an AI that can simulate those 1,000 filaments in seconds.
And it would actually understand the physics?
It understands the physics, it predicts the properties, and it tells you, build this one. It just compresses the timeline of discovery from decades to days.
Okay, so that's science. But if you have an AI that can invent new chemicals, that sounds a little risky.
It does.
If it can design a cure, can it also design a poison?
And that brings us directly to pillar 2, safety and ethics. This is where that Tony Stark analogy comes back in a big way.
The goal is to build Jarvis, the helpful assistant.
Not Skynet from the Terminator.
Which is a valid concern. I think we've all seen enough sci-fi movies to worry about the Skynet angle.
Oh, Hassabis knows this. He's very aware of that cultural fear. That's why a huge part of the roadmap is collaborating with groups like the UK AI Security Institute.
So they're prioritizing AI safety from the start.
It's a prerequisite. They want to test these models for extreme risks before they're ever released.
Yeah.
It's all about building provably safe systems.
Measure twice, cut once. Or simulate 1 billion times, release once.
Precisely. Then we get to pillar 3, which I think is going to be the most visible change for us regular people, physical agents.
This is the real world stuff?
Moving from the screen to the street.
Yes, the transition from chatbots to what they're calling Gemini robotics.
The goal is to have robots that can actually understand and manipulate objects in the real world.
So agents that don't just process text but can, tidy up a room or fix a machine.
That's the ambition. And it sounds simple to us picking up a glass of water, but for a robot, that is incredibly difficult.
You have to understand friction, weight, fragility.
That if you knock it over, it makes a mess. Hassabis wants to build an AI that understands the physics of the world, not just the language of the internet.
Okay, and that brings us to pillar 4, which sounded a bit more aggressive in the notes.
Global competition.
Yeah, Hassabis used a specific word to describe the market back in January 2026. He called it
Ferocious. It really feels like an arms race.
Google, OpenAI, Meta, everyone is just throwing billions and billions at this.
It is a race. And
Right.
Google is investing in these massive data centers to train the next generation models like Gemini just to stay ahead.
He admits it's a bit of a bubble, right, in terms of funding.
He does. He says there's so much capital chasing these ideas, but he believes the real value at the end of it is so high That the investment is more than justified. He's playing to win.
Okay, so we have science, safety, robots, and a ferocious race to the top. But the burning question, the one I always have, is when?
The when question.
Yeah, when does the sci-fi stuff actually happen? I'm still waiting for my flying car.
Well, according to Hassabis' predictions at Davos 2026, you might get the robot before the flying car.
The timeline is surprisingly tight.
It is. For the summer of 2026, so basically right now, the roadmap points to a major expansion of this physical AI.
So that includes things like AI glasses and these world-aware robots.
World-aware. It sounds intense, doesn't it?
It does. What does that mean in practice?
It means they aren't just following a pre-programmed path. They're seeing the world and understanding it.
So glasses that don't just show you a text, but can see what you're seeing.
Exactly. You look at a broken engine part, and the AI highlights the specific bolt you need to turn. It understands the 3D reality you're in.
That's handy. But the bigger milestone in the notes was the 2026 to 2027 window.
Right. This is where he predicts we reach basic AGI.
Basic AGI. So AI that's better than a human expert at specific complex tasks, but maybe not everything yet.
Correct. But the key technology that unlocks this is something called world models, like their new system, Genie 3.
Okay, stop there. World models. This is important. This isn't just the language model predicting the next word in a sentence, right?
No. And this is probably the most important technical distinction to get. A large language model, like the chatbots we have now, predicts that after the word apple comes the word pie.
It's statistical. It's about words.
A world model simulates the reality of an apple.
So it runs a little physics simulation in its head.
Exactly.
Yeah.
It understands that an apple is a solid object.
Yeah.
That if you drop it, gravity pulls it down. That if you bite it, it makes a crunch. It simulates the outcome of an action before it takes the action.
So if a robot has a world model, it doesn't just see an apple as a bunch of pixels.
It understands the physics of how to grab it without crushing it.
Or dropping it.
Right. It can imagine the future. It can simulate, if I grab it this hard, it squishes. If I grab it this hard, it slips. It runs that simulation 1,000 times in a millisecond, picks the best outcome, and then acts.
That is a huge leap toward true intelligence.
It's a game changer.
Yeah.
And once you have that, an AI that understands the physical world, the timeline just accelerates.
Which brings us to the prediction for 2028 to 2030. Full AGI.
Full AGI. That's the holy grail. An AI that surpasses humans in almost every economically valuable task.
And the applications he lists for this period are staggering. Solutions for fusion energy, discovering entirely new materials.
Fusion energy.
That's been 20 years away for the last 50 years. Why does he think AGI can crack it by 2030?
Because fusion is fundamentally a control problem. You have to hold this superheated plasma stuff as hot as the sun inside a magnetic field.
But the plasma is really unstable. It wobbles.
It wants to escape. It's like trying to hold Jell-O together with rubber bands while the Jell-O is also on fire and exploding.
Okay, yeah. And humans aren't fast enough to adjust the rubber bands.
Exactly. We can't react quickly enough. But an AGI, it can monitor the plasma, run a physics simulation to predict how it will wobble in the next millisecond.
And adjust the magnets instantly to keep it stable.
Exactly.
So the AI stabilizes the reaction, and suddenly we have infinite clean energy.
That's the theory. And DeepMind is already collaborating with the U.S. Department of Energy on this exact problem. If they crack it, it changes everything.
It's incredibly exciting. I really want to be optimistic. But
It's always a but.
there's always a but in these deep dives. It can't all be smooth sailing. There have to be roadblocks.
Well, absolutely. The source material identifies several big redos or challenges, and this is where we hit the reality check.
Let's start with the one that hits home for a lot of people. Jobs. The labor market.
Hassabis is actually quite candid about this. In a conversation with Dario Amodei, the CEO of Anthropic, he admitted that AI is already cutting entry-level jobs.
The notes mention coding specifically. That used to be the safe career path. Learn to code, everyone said.
Right. And the nuance here is important. AI isn't writing, massive software architectures from scratch yet.
It's not designing the whole system.
But it's editing code, it's debugging, it's doing the grunt work the junior coders used to do.
So the role of a junior coder is changing from writing code to supervising an AI that writes code.
Exactly. Which makes senior developers insanely productive. But it raises a huge question. If you cut out the entry-level jobs, how do people ever become senior experts?
That's the apprentice paradox.
If the AI does all the learning tasks, how do humans learn? It's a real challenge. It requires a massive retraining of the entire workforce.
We have to learn to be the architects, not the bricklayers.
We have to move up the value chain. But, there is an even bigger risk than the economy.
Here we go, the great filter.
The source mentions the Fermi paradox. You know the question. If the universe is so big and so old, where are all the aliens?
Right. And the great filter theory is that civilizations just inevitably destroy themselves before they can get to the space traveling stage.
And the big scary fear is AI, that filter.
Is AI the technology that gets too powerful for us to control and it just ends up destroying us?
That is a terrifying thought to drop into the conversation. Hey, thanks for tuning in. We might be the filter.
It is, but honestly, that fear is why DeepMind puts so much emphasis on tools like Gemiscope.
What is that? It sounds like some kind of medical device, basically a tool to audit the AI. Right now, these massive neural networks are like black boxes. We feed data in, we get an answer out.
But we don't really know how it got the answer.
Which is fine if it's recommending a movie. Not so fine if it's controlling a nuclear reactor.
Right.
Gemiscope lets their engineers look inside the neural network, literally look at the layers of neurons and see what concepts are activating. They wouldn't be able to spot deception or dangerous planning or bias.
Before it happens.
Before it happens. They're using AI to police the AI.
An arms race between the capability of the models and our ability to control them.
In a way, yes. And then, of course, there's the money aspect, the bubble.
The economic risk. There is just so much money flooding into the space, trillions of dollars.
The risk is that we're in a hype cycle that could just burst.
Are we buying pets.com or are we buying the internet itself?
Hassabis argues that unlike the dot-com bubble, where people were investing in websites with no business plan, the underlying technology here has real, tangible value.
AlphaFold actually works. It actually finds new drugs.
Coding assistants actually write code. The utility doesn't disappear even if the stock prices crash. The science is real.
The value is in the solved problems. So let's wrap this up. We've looked at the man, the plan, the timeline, and the risks. When you step back and look at this entire roadmap, what is the big takeaway for you?
For me, the message is that AGI is not a matter of if. It's a matter of when.
And looking at this roadmap, when is very, very soon.
But the real so what here is fascinating. The source material argues that we as humans need to shift our self-image.
Shifted how?
We have to stop defining ourselves by our ability to do tasks. The AI is going to do the heavy lifting.
It'll optimize the logistics, it'll fold the proteins, it'll write the code.
Right. We have to become the architects. Our value isn't in the labor, it's in the direction.
Our superpower becomes creativity, asking the right question.
Exactly. AlphaFold can answer any biological question you give it, but it doesn't know which disease to cure first. It doesn't know what matters to humanity. That is still on us.
That's a hopeful spin on it. The AI is the engine, but we're the steering wheel.
Precisely. If we are left with the dreaming while the AI does the doing, that could be a golden age for humanity.
But only if we're ready to define what we actually want.
And that's the tricky part, isn't it? Knowing what to wish for when you finally get the genie.
And knowing how to make sure the genie stays in the bottle.
Well said.
All right, here's my final thought for you to take away. And this comes straight from the source's final provocation, which I just loved.
Okay.
If AI can solve fusion energy, and it can solve climate change, and it can map every protein in the human body, can it finally figure out how to organize my messy desk?
Given the timeline for the robotics, ask me again in the summer of 2026.
I will mark my calendar. Thanks for joining us on the Dope Dive.
A pleasure.
Stay curious, everyone. We'll see you in the future.